Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Okay. Good afternoon, students. Let us start the session. So I'm audible to all of you. Please confirm. Please let me know I'm audible. If yes, please message me yes in the chat box. I'm audible to all of you. Okay. Anyway, let us start. Right. Okay. I hope the screen is visible and I'm audible also. Let's start. Today we are going to start with print and println methods in Java. We'll study first system.out.print method, and we'll also see what is the system.out.println. Okay, so both the methods are different methods. We should know the difference between these methods. Very important. So frequently these methods are used while writing programs. So let us see these methods. First is print method. It is system.out.print. In fact, system is a built-in class in Java, and this built-in class has a member called as out. Out is a member object of system class, and this out object is used to access this print method. So this print method, whenever we want to print something, what it will do now, it will print the message, it will print the result, thereafter retains the cursor on the same line. It displays the result, keeps the cursor on the same line. It doesn't send cursor to the next line. The cursor is kept on the same line. So if we display the next output, that also will be displayed on the same line itself. Okay, so that's the important thing to know about print method. It displays the result, keeps the cursor on the same line. Next result will also be displayed on the same line itself. Okay, how about this println? It is little different. It displays the result, thereafter sends the cursor the first column of next line. Okay, after displaying the result, it will send the cursor to the first column of next line. So if we display one more output, that output will be displayed on the new line, next line. Okay, so that is the basic difference between print method and println method. We are going to see these two methods in action. We'll write a simple program and understand how they work. Okay, so let us start this. I'll create a class called main. Java is a strictly object-oriented programming language. Each and every piece of code should be within class itself. That's why every time class need to be defined. I have a class called main here, and inside this class, I'll define main method, public static void main. Main method is the entry point of a Java program. It is called as entry point because always execution of a Java program starts from the main method itself. If your class has main method, you can execute it, you can run it. If class does not have main method, execution is not possible. That's why whenever you want to run your program, ensure that that class has main method in it. Okay, this is main method. And here need to write string followed by args. It's an array of string class type. Okay, here I'm going to write SOP state that system.out.print method, system.out.print. Okay, see here, first I'll display apple as the fruit name. Thereafter, I'll display one more fruit. I'll write like this, system.out.print. So this time it is banana. The fruit name is banana. Thereafter, one more fruit I would like to display, system.out.print, say mango. So three fruits I'm going to display here. What I expect is apple should be displayed on first line, banana should be displayed on second line, and mango should be displayed on third line. So that is my requirement. But output will not be like that. Apple, banana, and mango all will be displayed on the same line because we are using print method. Okay, let us see the result first, then come back to the code and try to understand it in a better way. Okay, so let me save this code first. File menu, click on the save button, save menu option. I'm going to save in C drive. This is my C drive. Here I have a folder called Java. Open the Java folder and save it. Okay, I'll call it as sop.java. The file name is sop.java. Okay, now it has to be compiled. To compile our code, what is required? Java compiler required. What is required? Java compiler required. To execute our code, what is required? JVM required. So we have installed the software already. Okay, we can just make use of Java compiler and Java virtual machine. Okay, so let us open command prompt. Here in search box, I just type CMD. Command prompt is displayed. Double click on it. It will be opened. Let me maximize it. It is maximized. It is showing some other directory, users GT0156. This is not the folder where I have kept my code. Okay, so let me come out of this folder first. I'll come out of this directory, cd backslash. I came out. Now I'll change to the directory where I have kept my code, cd Java. In C drive, under Java folder, I have kept my code, cd Java. Okay, let us go and check the folder. I'll show you first. C drive. See this? This is the folder. If I open, I'll get so many programs. Yesterday we studied, right? Those programs. And today's code is here, SOP. Now what's the type of the file here? Java. It has to display Java. In case if the file is not saved properly, it will display text here. If it displays text means the file is not saved properly, it is not possible to compile and execute. So in my case, the file is saved properly. I can compile and run it. Okay, now let us come back to the command prompt. Okay, let's compile the code. Java C space file name. What is the file name? sop.java. Okay, this is going to compile. Yes, the code is compiled. A dot class file would have been created now. Let me take you to that dot class file and show it. Okay, go back to the same directory, or you can say folder. It would have created dot class file. You can see here main.class. My file name is sop.java. In that file, there is a class called main. So that main class is compiled and it has generated dot class file. This is compiled Java code. And you can see the date also 11/6/24 it is showing. 15/11 time also it is showing. It's a dot class file. It consists of bytecode instructions. We compile Java source code to bytecode. So this main.class file would contain bytecode instructions. It can be executed with the help of JVM. Let us do that. Now, let me go back to the command prompt. Try to run it. Java. This is the command. Java is the command. Java stands for, okay, in fact, Java is Java application launcher. It is going to load JRE in the memory. Then JRE will execute our program with the help of JVM. Let us run it. Java followed by the class name should be mentioned. Class name is main. Mention the same thing. No extension should be there. Java main. Enter. See the output is shown here. What is it showing? You can see apple is shown, banana is shown, mango is shown. All the three names are displayed on the same line. This is not what I wanted. In fact, I want apple in the first line, then banana on the second line, mango on the third line. That has not happened. And why is it displaying like this? Because of the print method, system.out.print method. Let us try to understand that method. Okay, let's go back to the code. What this did know, this SOP statement initially displayed apple. Okay, is it displayed? Yes, apple is displayed here this much. After displaying the apple, this SOP statement did not send the cursor to the next line. The cursor was retained on the same line. Okay, then this SOP statement executed to display banana. Now you can see banana will continue here. See, after apple, banana is displayed here. Okay, it did not go to next line. This is also system.out.print method itself. It displays the result, keeps the cursor on the same line. Cursor does not go to the next line. Okay, cursor will be on the same line. Then this SOP statement will execute and display mango. So mango also will be displayed on the same line itself. And because of this nature of SOP statement system.out.print method, we get all the three fruit names on the same line. This is not what I wanted. I wanted line by line display. So that can be done by using system.out.println method. Let me show that to you now. I'll just save this file. I'll make a copy system.out.println.java. Okay, this is different file. This is different file. That file is there. This is different one. And here, extra of print method, I'm going to use println method. LN. LN stands for new line. What this println method will do now? It will display the message. It will display result. Then immediately it will send the cursor to the next line. So the next output will be displayed on the next line. Okay, here also I'm going to use println itself. Okay, here also, no problem. I can use here also println. Now, let us see the output first. Then we'll come back to the code to understand it in a better way. Okay, let me clear the screen. Java C SOPL. This is a different file. I need to recompile it. I need to compile it. Okay, system.out.println Java. The code is compiled. It would have generated .class file. Now I'll just run that .class file. Java followed by the class name. What is the name of the class? Main itself. I'll just give main, M-A-I-N. Main is the name of that compiled Java class. Just give it, enter. See this, I got the required output. Apple, then banana, then mango. All the three fruit names are displayed on separate lines. This is what I wanted. Let us see how this has happened. Okay, here I'm using println method. Notice here, this is println method. So we write like this, system.out.println apple. This println method displays the output and after that sends the cursor to the next line, first column of the next line, like this. It will display the apple and sends the cursor to the next line. Cursor comes here. Cursor comes to the next line, here, this line. Okay, then this SOP statement gets executed. It will display banana. So banana will be displayed on the second line. See, the cursor was here. So on the same line, banana is displayed. After displaying banana, it will send the cursor to the next line. Cursor comes to the third line. Here it comes. Then one more SOP statement will execute. It will display mango. So we get mango here. Mango output is displayed. After displaying this mango, this println method will send the cursor to the next line. So cursor comes to the next line. That's why we have this gap here. I displayed only three fruits names. So line by line, they are displayed. So got the difference between print method and println. So any doubt? Anybody has any doubt? Any queries? Any doubt? Any queries? Okay, what is the difference between print method and println? Print method will display the output and keeps the cursor on the same line. Okay, next output also will be displayed on the same line. When it comes to println method, it displays the output and sends the cursor to the next line. So the next output will be displayed on new line. So whenever we want print method, we should use it, and whenever we want println, we should use it. Both the methods are equally important, equally useful. Okay, so can you tell me where this print method is useful? Println I have shown you. To see the output line by line, println method is very much useful. Any idea where system.out.print method is useful? Any idea? Anybody can let me know where is it useful? Guess. You can message me. Meanwhile, I open that file. Tell me, where is print method useful? I said both the methods are equally important. Okay. So tell me, where is print method useful? This one. The one we studied here, no? It displays apple, banana, mango on the same line. Where is it useful? Anybody can let me know? Anybody? Okay, let me save it. So the one.java I have given. I'll show you where is it useful. Okay, now I'll just cut this. Here, I'm going to display. Okay, number one I'm going to display. Thereafter, one space plus double quotes, one or two spaces. Okay, within double quotes. This is space. Intentionally, the space is given. What I'm doing here now, I will show you how we can use print method to generate matrix display. Matrix looks like this, no? 1, say 2, 3. 1, 2, 3. 1, 2, 3. This is matrix. How to display matrix like this? Okay, we have to make use of print method to display matrix like this. Okay, see here. You display this first digit by using print method. Okay, it will display the first digit. It will not send the cursor to the next line. Cursor will be on the same line. You give some spaces, then display next digit. And when you display the next digit, again use print method itself because one more digit need to be displayed on the same row. That's why display this two by using SOP statement system.out.print method. It will display 2 and retains the cursor on the same line. Give some spaces and then display 3. How to display 3? It has to be displayed by using print ln because we should display 3 and thereafter cursor should go to next line. On the next line, one more line of output can be displayed. So to display the first digit, we use print method. To display the second digit, we use print method. To display the third digit, we go for print ln method. Okay, and again, here also, we display this by using print method. This also print method. And this one we display by using print ln method. The last row is also like that only. Print method, and this is displayed by using print ln method. Let me show you one simple row. I'll generate a simple row and show it to you. Okay, here one is displayed. Now two should be displayed. System dot out dot print. Here I'll type two. Two should be displayed. Plus operator. Some spaces I'll give here. Okay. And then next digit. System dot out dot print. Here I'll display the third digit. 3 and some spaces I'll give. If spaces are not given, it looks like a single number. It doesn't look like a matrix row. That's why spaces should be given. Okay, the code is partially ready. Now I'm going to compile and run this code. Meanwhile, anybody has any doubt? Anybody has doubt? Any queries? You can ask me your queries. Hmm? Okay, let us compile this code. So I should know the file name to compile. The file name is sop1.java. Let us compile javac sop1.java. Okay, so it is showing one error. Luckily, it is showing error because I wanted to show you some error so that it can be solved in front of you. So error semicolon expected. What is expected here? Semicolon expected. Let's go back to the source code. See, after writing the last SOP statement, I did not put semicolon. I forgot to put semicolon. Put semicolon, save it. You have to save. Okay. Now come back to the command prompt. I'll clear the screen. Okay. Now let me recompile it. Javac SOP1 Java. Compilation is done. Now run it. Java followed by class name should be used for execution. For compilation, file name should be used. For execution, class name should be used. Java followed by main. Okay, enter. See, it is showing one row. One, two, three. One row it is showing. The same way, if I display two more rows, it looks like a matrix. What I'll do is, I'll send the cursor to next line now, like this. System dot out dot print ln I write. Okay. After displaying this row, this println method is there now. It will send the cursor to the next line. On the next line, I can display one more row. Let me just copy this code. Let me copy this code, paste it here. Okay. This will display my first row. This will send the cursor to the next row. On the next row, this will display my second row. Then this is going to send the cursor to the next row. Now let us check what output is displayed. Okay, compilation is done. Yes, whenever we make changes to the source code, then we have to save and recompile the program. The file has to be recompiled. Okay, Java followed by the class name main. See, two rows of matrix are displayed. Now one final row required. That also let us generate. Copy this. Okay, paste it. This much is enough. One more SOP is not required here. This much is enough. It will be able to display all the three rows. That's what we wanted, right? Okay, now recompile, re-execute the code. See, matrix is displayed. I'm getting matrix display here. In fact, this is not the way we generate the matrix because it is taking so many lines of code. We can optimize this code by using something called as loop. We can make use of something called as for loop and write efficient code to display the matrix output. But as of now, you are not aware of that for loop. For loop is not yet covered by me. That is the reason in this approach, I am showing you how to generate the matrix display. Okay. Now, instead of using print method, what if I use println method everywhere? Let me show you what happens. See, I will not be using print here. I'll go for println. Here also println. Even here println. Even here println. Okay. No print method at all. Everywhere println. Okay. Even here println itself. I saved it. This also make println. Now see, it will display like a column, single column. Compilation is done, executed. See, it will display like this, single column. It is not at all my matrix display, but I want matrix output. Then we should go for print method. So when we use print method and println method together, it is possible to generate matrix output. So let us go back to the previous output, remove all println. Okay, from here also I'll remove, from here also I'll remove, from here also I'll remove, last one. Okay, it is removed, save. Now see, again our matrix will be back. See, matrix is displayed. I hope you understood the difference between print method and println method. So anybody has doubt, any queries, can ask me, any doubt, any queries, any questions, any comments? Anybody? Am I audible to all of you? Can you hear me, students? Okay. Okay, no problem. Let us continue. I hope you have understood the concept. Okay, let us continue. Any doubts you have, you can ask me. Now, moving down, create. Okay, say this now. Normally, we write this kind of expressions, right? X is equal to say 10, okay, y is equal to say 20, okay, let me remove, and z is equal to x plus y. This kind of calculations normally we do in mathematics, we do in programming also, we do it. Okay, that's why whenever we do any calculation, we'll be using something called as variable. You can see here, you can see this. I'm assigning value 10 to x. It means value 10 is stored in x, value 20 is stored in y, and x and y both are added. The result is stored in z. That's what I'm doing here. Is right. So before we store any value in x, we have to clearly mention x should store what type of value, whether it has to store some whole number or decimal number, that has to be mentioned. Okay, somewhat like this. Integer value. X has to store whole number, integer value. Now let us make y some decimal value. Okay, y has to store what? Some decimal value, some floating point number. That also we should mention clearly. Float y is equal to 20.0. And what will be the result of x and y? Obviously, it is also going to be some decimal value itself. So that result we are going to save in z variable, in this z. So we have to mention what data z is going to store. Z also will be storing float itself. Okay. Before assigning, before storing any value in any variable, this can be called as variable. Okay. Before storing any value in any variable, so clearly we have to specify what type of value the variable should store. We have to declare as the variable is going to store what type of value. Once it is done, values can be stored in that variable and we can do calculations also. Then what is this? What is this int? What is this float? They're called as data types. In Java, we have 8 different data types. Using these data types, we can clearly mention what type of value we can store in a variable. That's why to write mathematical programs, it's very much important to know the different data types we have in Java. So we have 8 primitive data types in Java. We are going to study those data types now. Anybody is aware of data types in Java? Anybody knows it? Anybody knows it? Data types? Anybody? Give me a moment. Let us continue. There are 8 primitive data types in Java. We'll see those data types, no problem. I'll increase the font size a little bit. Okay, it is 18, right? Okay, no problem. No problem. Mm, Here, data type, I'm going to specify. Okay, here, size, I'm going to specify. Here, default value, I'm going to specify. Okay, okay, okay. Let's see the first data type. It is called as byte. Byte is a primitive data type in Java. It supports numerical values. If you want to store any numeric value in a variable, then byte data type can be used, but only for small values. It does not support very big values. Only small values can be stored with the help of byte data type. Why small values only? Because its size is very less. it occupies 8 bits of memory. Okay, so byte data type occupies only 8 bits of memory. That's why small values it can support. And its default value is 0. It means in case if we do not initialize a byte variable, okay, to any value, it will be having default value 0. What will be the default value? It's going to be 0 itself. Then comes the next data type. It is called as short. Short is one more data type. This data type also supports numeric values only. Okay. The size of this data type is 16 bits. It means it occupies 16 bits of memory to store numeric value. Okay. So as it is 16 bits, it is bit bigger than the byte. Okay. Comparatively, we can store larger values in a variable of short data type. Okay, in case if a short variable is not initialized, if you do not initialize it, then it will be having default value 0. Let me explain this to you. Okay, I would like to create one byte variable. We do it like this. Data type byte, then variable name, say x, then initialize it to some value like 10. This is called as variable declaration. Okay, this is how we create variables. Data type is specified, variable name is given, and values assigned to it. Okay, this value will be stored in this x variable. Later on, we can use it to do some calculation. Okay, what if I do not initialize it? If I do not initialize the variable to any value, so it will be having default value. What's the default value for byte data type? It is 0. So this is going to have 0 as the default value. The same way, let us create one short variable like this. Data type is short, variable name, some meaningful variable name. Okay, initialize it to required value, say 20. Okay, so what is the value of this y variable? 20. What if I do not initialize it to any value? Then it will be having the default value 0. Got it right? And the concept of default value is not applicable to local variables. It is applicable only to something called as instance variables and static variables. For local variables, default value concept is not applicable. We will study it in the example I'm going to demonstrate what is default value, what happens if default value is not there. We will come to know. In example, we are going to study it. Okay, how to create variable I showed. Now let us continue with the data types. Byte short int. Next data type is int. It is going to occupy 32 bits of memory to store the data. How much memory it is going to occupy? 32 bits of memory. That's why it can store bigger values comparatively. What if I do not initialize an int variable? It also will be having default value 0. Okay, then comes next data type. It is called as long. How much memory it is going to occupy? 64 bits of memory. Big one. 64 bits of memory it is going to occupy to store single value. In case if I do not initialize it, it also will be having 0. Okay, now let us see one example here. See this. I'll declare a variable called variable of long data type. Okay, it is x. I'll store value, say 1000. Okay, value 1000. What's the data type of this x variable? Long. What value it is storing? 1000. How much memory it is going to occupy to store 1000 value? 64 bits. It's going to occupy 64 bits. Okay. Now, I'll reduce the value to 100. Now, how much memory is occupied by this x variable to store 100? Now, so 64 bits itself, because the size of long data type is 64 bits. Whenever we create any variable of long type, it is going to occupy 64 bits of memory to store the value. Okay, I'll further reduce the value to 10. How much memory it is occupying? 64 bits. Now also 64 bits. Now delete it. Okay, keep only one. How much memory it is using? Now also 64 bits. Now 0. How much memory it is occupying? 64 bits of memory itself to store that 0. Got it right? If you declare a variable of long type, it is going to occupy 64 bits of memory irrespective of what value you are going to store in it. You may store 0 or you may store maximum positive value or negative value. Then also it is going to store then also it is going to use 64 bits of memory itself. And the same concept is applicable to these data types also. If you declare a variable of int type, it is going to occupy 32 bits of memory. You may store 0 or you may store 100 or you may store maximum value. It is going to occupy 32 bits only. Then short. If you create a variable of short data type, it is going to occupy 16 bits of memory irrespective of value that you store in it. You may store just 0 value or you may store 100 or 200. Then also it's going to be 16 bits itself. The same way, byte also. If you create a variable of byte data type, it is going to occupy 8 bits of memory irrespective of what value you are going to store it. You may store 0 or you may store 125. So 8 bits of memory itself, it is going to occupy. And this concept is same for all the data types. Okay, let us continue with the next data type. Next is float data type. What is the size of float data type? It is 32 bits. It's going to occupy 32 bits of memory. And what's the default value for a float data type? It is 0.0 F. F has to be there. F suffix has to be there for float values. In case if this F suffix is not there, then it is treated as double value. It is treated as double data type value. That's why whenever you create or whenever you write float type values, that F suffix has to be there. Please ensure F is there. Now the question is whether it should be say capital F or small f. Does not matter. You can write small f or you can write capital F. Does not matter. That suffix is not case sensitive. Java is case sensitive. Java is case sensitive, but that suffix is not case sensitive. You can write in uppercase or lowercase, does not matter. So we use float data type to store decimal values. To store floating point values, float data type is used. Then comes the next data type. It is called as double. So how much memory it is going to occupy? 64 bits. What's the default value of double data type? 0.0. In case if you do not initialize your double variable to any value, it is going to store 0.0. So that is double data type. Then comes next one. Okay, Boolean. So there is no specific size for Boolean. It is JVM depend. And let's understand Boolean type. Why do we use Boolean data type? To create a variable which stores either true or false. Yes, sometimes we need to store true false values. In such cases, you can go for Boolean data type. Okay, what's the default value for Boolean data type? It is false itself. And how much memory a variable of Boolean is going to occupy? Precisely, it cannot be said. It may be 1 bit, or it may be 8 bits, or it may be 16 bits. That depends on the JVM. Okay, the JVM can decide how much memory should be allocated for a Boolean variable. That's why we can't say how much memory is occupied by Boolean on different platforms. So that is Boolean. It is used to store true or false values. Boolean values. Okay, then comes the next one, char. The last data type is char data type. Okay, it occupies 16 bits of memory. How much memory it occupies? 16 bits of memory to store char values. And what's the default value for char? So it is like this, backslash u followed by 000. That is null character. What character? Null, Null. null character. Okay, in case if you want to store alphabets or special characters, okay, then you can go for char data type. Somewhat like this. Let me show it to you. Char x is my variable. In this x, I can store, see, alphabet capital A. I can store. Okay, and if I display it using system dot out dot println, and if I display that x, what will be displayed? A itself will be displayed. The output will be A itself. And what else I can store in this character variable? I can store special characters like dollar sign can be stored, caret symbol can be stored, ampersand can be stored, percentage can be stored. Whatever special character you want, you can store it. Whatever alphabets you want, maybe uppercase, lowercase, does not matter, you can store. You can store digits also. Okay, this is also possible. Basically, it's a character. Digits are also characters. Okay, some characters are used as alphabets, some characters are used as digits, some characters are used as special characters. All of them are basically characters only, but we have classified them as alphabets, special characters, and digits. So here one important thing you should know, this 5 is there, no? 5 is written within a pair of single quotes. That's why it is a character. In case if I write only 5 without any quote, then it is treated as a digit. When it is treated as a digit, arithmetic operations possible. You can add, you can subtract, you can multiply, all those calculations can be done. But this is within a pair of single quotes. It is treated as a character. Arithmetic operations not possible with it. Okay, it is not possible to do addition, subtraction, multiplication because it is a character. It is treated as a character here. So got the difference right? So this, okay, if you write like this, it is different. If you write like this, it is different. It is a digit. It is a character. Arithmetic operations not possible with characters, but with digits, it is possible. It's a numeric value. Any doubt? Any query? Any questions? Anybody? Any questions? Any doubt? Okay, these are the basic data types we have in Java. Okay, so how many data types are there? There are totally 8 primitive data types we have in Java. See here, byte, short, int, long, float, double. These data types are used to store numeric values. To store and manipulate numeric values, we use this data types. To store and manipulate Boolean values, that is true and false values, we use this Boolean data type. If you want to store and manipulate characters, this data type is used. Which data type? Char data type is used. Got it? Altogether, there are 8 primitive data types in Java. How many primitive data types we have? 8 primitive data types are there in Java. Okay, so is it clear? Any questions you have? Anybody? You can ask me. Any doubts, queries? Any questions? Okay, let us continue. Now, using these data types, we create variables. Yes, right? We create variables. What is variable then? Question mark. What is a variable? Anybody knows the answer? Can you give me the answer? What is it? Okay, I'll tell you. Variable is a named storage location. I'll write here. Variable is a named storage location where we store a data of specific data type and manipulate it. Manipulate. Okay, that is variable. What is variable? It's a named storage location where we store data of a specific data type and manipulate it. It's a storage location. Variable is nothing but a storage location. We give some name to that location. We store some data of a specific data type. And that data can be manipulated also. What is the meaning of manipulation? Simple. The data can be incremented. The data can be decremented. So this kind of processing is called as data manipulation. Okay, data stored in a variable is not fixed. It is not constant. You can manipulate it. Data can be modified. You can increment, you can decrement. So that kind of manipulation possible if data is stored in a variable. Okay. Then there is a term called identifier also. Have you heard of it? Identifier. So what is identifier? What is the difference between variable and identifier? Anybody can let me know? Tell me what is identifier? Anybody? What is identifier? Any answer? Okay, I'll tell you. Identifier is a name. Identifier is a name of some variable, maybe class name, maybe function name, maybe object name, maybe interface name, maybe annotation name. Identifier is nothing but name. Name given to a variable, class, object, function, interface, annotation. All of them is called as identifier. Okay, so variable means storage location where we store and manipulate data. Identifier is a name of a variable, class, function, etc. Okay, whenever we give name to any variable, class, function, we need to follow some rules, and they are called as identifier naming rules. Okay, this I'll write first, then we'll continue with it. Identifier is a name of variable, object, class, method, interface, etc. It's a name of variable, object, class, method, interface, etc. Okay, so whenever we create identifier, we need to follow some rules, and those rules are called as identifier naming rules. We need to know those rules. Let me show you those rules. So here it is identifier naming rules. Identifier naming rules. We are going to study it now. So what are the identifier naming rules? Okay, see, only these characters are supported when we create identifier. Capital A to Z. Okay. Small a to Z. Okay. 0 to 9. These digits can be used. And only two special characters allowed. The first special character is underscore. Okay. Let's see. Okay, 1 minute. This is new laptop. Where is the underscore here? Underscore. And then dollar sign. So only these characters are supported in identifier naming. Your identifier can consist of only these characters. Other characters not allowed. Not at all allowed. So this is first rule. Only supported characters are capital letters A to Z, small letters A to Z, 0 to 9 digits, underscore, and dollar sign. Other characters not allowed. Okay, what is the next rule? The next rule is keywords cannot be used as identifiers. In Java, we have many keywords. Around 50 keywords are there in Java. Those keywords cannot be used as identifiers. Then what is the meaning of keyword? It is a built-in word. Keyword is nothing but predefined word with predefined meaning and functionality. Okay, that's why we cannot use those keywords as our identifiers. So the point is, keywords cannot be used as identifiers. We'll come to know. All the keywords we'll be studying in Java, so we'll come to know. Then comes the third point. Identifier should not start with a digit. This is very important. Identifier should not start with a digit. Digit can be a part of your identifier, but identifier should never start with a digit. Important. Identifier cannot start with a digit. Remember. So these are the basic rules to be followed whenever we name any programming element in Java. Whenever you create any identifier, please do follow these rules. Okay. Now, I'll show you some valid and invalid identifiers so that you will get the concept properly. So first I'll show you valid identifiers. Valid identifiers. Some examples, that's it. Okay, valid identifiers. Anybody can let me know valid identifiers? Okay, I'll show you. Amount is a valid identifier. How can I say valid identifier? See, it is using only small letters. Valid. The list is saying no. A to Z small can be used. A to Z capital can be used. 0 to 9 can be used. Underscore can be used. Dollar sign can also be used. Okay, it's valid. Now, underscore amount. This is also valid. It starts with underscore, no problem. Moreover, underscore is supported, no problem. Then dollar sign. Where is dollar sign? Amount. This is also valid. Okay, your identifier can start with a special character or alphabet. Okay, it's valid, no problem. And then, so here I'll write one more. So that is amount 123, valid. Here I'm using a number. Digits are there. First digit, second digit, third digit. Is it valid? Yes, your identifier can have digits. It can have a digit or digits, but not in the beginning itself. If it is there in the beginning itself, it is error. If it is there somewhere in the middle or at the end, no problem. It is not going to create any errors. It's valid. Okay, so now I'll write like this. Uh, so somewhat like this. Dollar sign, amount, underscore, 12345. Is it valid identifier? Obviously, this is also valid identifier. Now one more. Int var. Is it valid identifier? Yes, it is valid identifier. And listen, if I write only int, it is not valid identifier. The reason is this is a keyword in Java. Int is a keyword and keywords cannot be used as identifier. That rule we have seen. Okay, if I use only int, it is not going to compile. We are going to get error. But I can write like this. Int x is valid. Int var is valid. This is not keyword. This is not keyword. Keyword is a part of identifier. It will not create any problem. Like this, you can create valid identifiers in Java. I'll show you some invalid identifiers also now. Let us see invalid identifiers. Invalid identifiers. Okay, so 9 amount. It's invalid. Reason? It starts with a digit. An identifier should never begin with a digit, should not begin with a digit. So see here, the first character itself is digit. So invalid, not possible. It will give us error. 1 minute, where is my data? It's here. It is invalid. Okay, 123. It is full of digits. It is also invalid identifier. Thereafter, so amount at the rate of 10. This is also invalid identifier because we are using at the rate special character. Only two special characters are allowed. The first one is underscore and the second one is a dollar sign. But this at the rate cannot be used. It is not supported. So that's why it is invalid identifier. Okay, the next one, hyphen amount. Is it valid? No, this is also not valid. The reason is it begins with hyphen. Hyphen special character is not allowed in identifiers, so you can't use it. Got it right? So hyphen is not allowed. You can't use it. Then next one, I'll write like this: class. Is it valid? It is not valid. The reason is class is a keyword in Java. Okay, keyword cannot be used as identifier. If you still use it, it will result in error. Okay, how about int? Int also cannot be used. It's a keyword in Java, cannot be used. Keyword can be part of identifier, but keyword itself cannot become identifier. Keyword can be part of identifier, but keyword itself cannot become identifier. Okay, now one more I'll show you here. So interest space. See here, what is used as special character here? Space is used. Space is also a character in programming. It's a special character. So I have two words here. The first word is interest and the second word is amount. Between these two words, space is used as a character, not allowed. Okay, this special character is not allowed. It cannot become the part of your identifier. This is also invalid. Got it? So special characters like at the rate cannot be used, ampersand cannot be used, hyphen cannot be used. They should not begin with a digit, and keywords cannot be used as identifier. So you have to remember all these rules to create your identifier. Okay. Anybody has doubt now? Any questions? Any queries? Any queries you have? You can ask me. Students, can you hear me? You have any doubt? Any queries? Any questions? Okay. So that's it for today. So we'll continue in the next session tomorrow. Okay. Let us complete the session, today's session.